Hey Math 1, I've got a new video for you to start out Chapter 7. And it looks a little bit like what we were doing in Chapter 6, except there's really not going to be much graphing. So to start, I'm going to graph something, just to give you guys some perspective on what we're doing. So, we graphed systems of equations and inequalities all during Chapter 6. So here's an example of one of the systems that we have. Y is already by itself in this equation, so I just rewrote it with a slope of 1 over 1, since there's nothing in front of x. And then here I got it in slope-intercept form. I got y by itself, and this is what I came up with. So, the only thing we know how to do at this point for solving systems of equations is to graph both lines and then see where they intersect. And then I can do that right now. This one starts at 1, 2, 3, 4 on the y-axis. And it goes up 1, right 1, which is the same as going down 1, left 1. Now for our purple equation, the graph starts above here 2 units. That's super inconvenient, so what I'm going to do is I'm going to say, let's pretend we're at 9 on the y-axis. I'm not going to plot a point per se. What I'm going to do is I'm going to say, hey, we know that you go down 3 units from 9. So what I'm going to do is I'm going to subtract 3 units from 9, and it's going to end up at 1, 2, 3, 4, 5, 6. Okay? It's going to be start at 9, go down 3 units, and then right 2 units. So there's the first point that I'm going to plot. I don't have to necessarily plot the point on the y-axis to get a point on that line. And then I can continue from there, down 3, right 2, down 3, right 2, and then connect my dots to form a line. You should probably use a ruler in these situations. At any rate, this gives us a solution of right 2, up 1, 2, 3, 4, 5, 6. So, that's a system of equations, and we know how to do this solving with graphing. That was just kind of a tricky situation where I had to use sort of like an outside-the-box idea to get the first point plotted on there. Now, what I'm going to introduce to you today is a non-graphing method for solving a system of equations. I'm going to get this as my answer at the end, but I'm going to use absolutely no graphing at all. And here's what it looks like. Instead of getting y by itself for both equations, what I'm going to do is I'm going to say, I recognize that there is a y here and a y there. There's a y in my first equation, there's a y in my second equation. If I were to take this y value and consider it as, hey, let's consider this as a black ink y, okay? Everything else is purple except that y is a black ink. What I can do is I can say this y has the same value as that y, who can be defined as x plus 4. So what I'm going to do here, it's kind of tricky, it's outside the box, but I am going to replace that y with the x plus 4. I'm going to put grouping symbols around it to say I'm multiplying 2 times x plus 4. And that all equals 18. Now what I did here was I substituted the x plus 4 from the first equation in place of the y in the second equation. And what that substitution allows me to do now is to solve an equation. We're back to Chapter 2, solving equations. How do I solve equations? You get rid of parentheses using the distributive property. So it's going to be 3x plus 2x plus 8 is equal to 18. Combine the like terms that we can. get the constants to the same side, and then divide by 5 at the end. X equals 2. Makes sense. Now, how would we find the y value? Easy. You just say, wherever I see an x, I can replace it with 2. So particularly that top equation, we're trying to solve for y. Why don't we just say y equals that 2 plus 4. 2 plus 4 is 6. Okay. Y equals 6. X equals 2. Now we know that 2, 6 is the solution, and we didn't even have to graph anything. Now, I know what you guys are thinking. You're looking at this and you're saying, I know how to graph lines. Why in the world would you want me to do this method at all? Well, 2 reasons. One, being able to do multiple things, being able to do the same thing with multiple methods means, hey, I'm seeing connections between both geometry, the spatial mathematics, and algebra, everything that can be computed and manipulated. 2, you guys are going to have to use substitution in future situations, future math classes, where it's not going to be nice and neat where it's going to be 2 lines intersecting, but it might be 2 different curves intersecting where it's like, I don't want to graph this at all. I just want to use the algebra to get x by itself and y by itself. So that's the substitution method. Okay? I'm going to do a few examples to just to get you guys familiarized with the procedure, and maybe put some step-by-steps off to the side so that you guys have something to work with. Okay? So example number 1. Yeah, we're going to try to answer that question if it's a valuable alternative to graphing linear systems. Regardless of whether it's a valuable alternative, it's going to be a necessary strategy for future mathematics. So, I got 2 equations. Here's what I need to do first of all. Step 1. I need to take one of the equations and manipulate it in such a way that I need to get x or y by itself. The reason is because the replacement requires you to get x or y by itself. Substitution requires us to choose an equation, probably the most convenient one, and I'll say to solve for x or y. To solve for either, not both, just either, for x or y. So right away, I'm looking at my top equation and I'm saying to myself, if I just subtract y from both sides, I have satisfied the requirements for step 1. Choose an equation, the first one, and I got x or y by itself. I solved for x. So x equals, and I always put the quantity in parentheses, right? Because when I'm going to plug it into the other equation, I need those parentheses to multiply through with the distributive property. So step 1, done. I got x by itself. Now we're ready to move on to step 2. Step 2, you take that expression and we are going to plug it in to where it belongs in the second equation. So if I get x by itself, that means I am going to replace x in the second equation. We're going to do a replace in second equation. So here's the replacement. That x is going to get out of there, and it's going to be replaced with 8 minus y. That's helpful because now we have nothing but y's as our variable in the second equation. So then we distribute 2 times 8, 16. I'm just going to get rid of the purple marker now. Minus 2y minus y equals 6. Solve an equation like you've normally done in the past. That's going to be 1y. You know what? I'm going to subtract the 16 at the same time that I add these two together. and I get negative 10, which divides by negative 3. A negative divided by a negative is a positive. Sorry, I should have given you guys more room for these notes. My bad. All right, it equals 10/3. Now that doesn't simplify anymore. It is 3 1/3. But yeah, at this point, I'm easing the burden of calculation by letting you guys use calculators on this, so shouldn't be a big problem. Just, there's no need to give decimals when a fraction works fine too. So now, I substituted. I got y by itself, or x by itself. I replaced it in the second equation. I solved. Okay, so I should probably say replace in second equation and solve. And then your third step is going to be plug in that result into one of the originals for y. That's just a fancy way of saying what answer did you get. Plug in the result to one of the originals. All right. Now, here's a quick hint. This equation that you did in step 1 is always the most convenient because it already isolated the variable you're looking for. I've got x, or I got y, I need x. Hey, x is already by itself right here. So I am choosing this equation to plug in for y, 8 minus 10/3. Okay. Now, you guys, again, you can use a calculator on this. I'm going to use it the old-fashioned way, finding common denominators. So that's going to be 24 minus 10/3, which is 14/3. Okay, we've got our answer. Our final answer needs to be written as an ordered pair because, again, this is a linear system that could be graphed, and the solution to that system is an intersection point. So 10/3 would be a y value, that'd be 3 1/3. 14/3, let's see here, it's almost 5. 4 2/3. I think I'm going to stop the video on this one and create another one just to give you guys a little bit of separation so you don't get that, what's that, foggy endurance? Just, you're like, I can't go through any more of these. Take a quick break, come back for the second video here soon.